5686. As altitude increases, the NV of a helicopter will A. Increase, B. Decrease, C. Remain the same. The correct answer is B. NV, or noise versus power, is a measure of how much noise a helicopter makes relative to its power output. As altitude increases, the air becomes thinner, which makes it more difficult for the helicopter's blades to generate lift. This requires the helicopter to use more power, which in turn produces more noise. In addition, as altitude increases, the helicopter is further away from the ground, which means that the sound waves have to travel further to reach the ground. This also contributes to the increased noise levels at higher altitudes. 5695. The anti-torque system fails during cruising flight, and a powered approach landing is commenced. If the helicopter yaws to the right just prior to touchdown, what could the pilot do to help swing the nose to the left? A. Increase the throttle. B. Decrease the throttle. C. Increase collective pitch. The correct answer is B. Cyclic control should be used to retain directional control most of the time, and momentarily applying throttle with the needles united to swing the nose to the right or depressing throttle to swing the nose to the left should be used as a secondary method. 5696. If anti-torque failure occurred during cruising flight, what could be done to help straighten out a left yaw prior to touchdown? A. A normal running landing should be made. B. Lake a running landing using partial power and left cyclic. C. Apply available throttle to help swing the nose to the right just prior to touchdown. The correct answer is C. If an anti-torque failure occurs during cruising flight and the helicopter experiences a left yaw, one possible action to help straighten out the yaw prior to touchdown is to apply available throttle to help swing the nose to the right. When the anti-torque system fails, the helicopter loses its ability to counteract the torque produced by the main rotor. As a result, the helicopter will tend to yaw in the direction opposite to the torque, in this case, left yaw. By applying available throttle, the main rotor's torque will increase, which can induce a rotational force to swing the nose of the helicopter to the right. This action helps counteract the left yaw and assists in straightening out the helicopter's heading. It is important to note that this action should be taken just prior to touchdown, as the pilot needs to maintain control and stability during the approach and landing phase. The exact technique and amount of throttle application may vary depending on the specific helicopter's characteristics and the situation at hand. 5697. Should a helicopter pilot ever be concerned about ground resonance during takeoff? A. No. Ground resonance occurs only during an autorotative touchdown. B. Yes. Although it is more likely to occur on landing, it can occur during takeoff. C. Yes, but only during sloped takeoffs. The correct answer is B. A helicopter pilot should be concerned about ground resonance not only during landing, but also during takeoff. While ground resonance is more commonly associated with landing, it can potentially occur during takeoff as well. Ground resonance is a phenomenon that can happen when the helicopter's rotor system and the helicopter's airframe resonate with each other due to an imbalance or misalignment. It typically occurs when the helicopter is in contact with the ground, such as during landing or takeoff. During takeoff, if there is an imbalance or misalignment in the rotor system, or if certain conditions are present, ground resonance can potentially develop. The vibrations caused by ground resonance can lead to severe oscillations that can jeopardize the structural integrity of the helicopter. Therefore, it is important for helicopter pilots to be aware of the possibility of ground resonance during takeoff and to take necessary precautions to prevent its occurrence. This includes ensuring proper maintenance, balancing, and alignment of the rotor system, as well as monitoring for any signs of vibration or instability during takeoff and promptly addressing them if detected. 5698. An excessively steep approach angle and abnormally slow closure rate should be avoided during an approach to a hover, primarily because A. The airspeed indicator would be unreliable. B. A go-around would be very difficult to accomplish. C. Vortex ring state could develop particularly during the termination. The correct answer is C. An excessively steep approach angle and abnormally slow closure rate should be avoided during an approach to a hover primarily because vortex ring state could develop, particularly during the termination. Vortex ring state, also known as settling with power or power settling, is a dangerous aerodynamic condition that can occur when a helicopter descends too rapidly with a high rate of vertical descent. It typically happens when the helicopter is in a low-speed, high-power situation, such as during an approach to a hover. If the helicopter is descending at an excessively steep angle and the closure rate of descent towards the ground, is abnormally slow, it creates a situation where the rotor blades encounter their own downwash. This downwash interferes with the inflow of air into the rotor system, causing a loss of lift and an increase in drag. The result is a rapid decrease in rotor efficiency and a potential loss of control as the helicopter enters vortex ring state. In this state, the helicopter can experience uncontrollable descent rates, erratic handling, and potentially lead to a loss of control and a hard landing or crash. Therefore, it is crucial to avoid excessively steep approach angles and abnormally slow closure rates during an approach to a hover to prevent the development of vortex ring state. Pilots should maintain a safe approach angle, ensure an appropriate closure rate, and be aware of the helicopter's performance limitations to maintain control and safe landing during the approach.